So now we are starting Unit 4, and today's lesson on 19-1 is about an arithmetic sequences. Okay, so we are in our Springboard book on page 295, so make sure you have something to write with, and you're probably going to want a calculator for today's lesson. Okay, so Unit 4 technically has kind of three different parts to it. We have series, exponential, and log functions. So we're starting with the first part, which is sequences and series. Okay, so let's look at page 295. So what we're going to be doing is seeing what makes a sequence arithmetic, talking about a common difference, and then writing expressions. Okay, so let's jump down to this part here. So any function where the domain is a set of positive consecutive integers forms a sequence. A sequence is just a list of numbers, okay? Usually it's formed by some kind of pattern, okay? So if we consider this sequence here where we have 4, 6, 8, 10, 12, and 14. That is a sequence because it's just a list of numbers. Okay? This, we're going to talk about a few things. Okay, so number 2 says, what's A1? Now here's just a little notation. A1 just means what's the first term. So that little sub number just means that term in the sequence. So in this particular problem, A1 is the first term in this sequence, which is 4. A3 then is the third term in the sequence, which is 4, 6 would be 8, the third number. Okay, so that little number just means that term in the sequence. Okay. Now, when we look at this sequence, we can see that they're talking about a common difference here. All that means is what is it going up or down by? So let's look at this particular sequence. It goes 4, 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. So how is that function changing? Okay. Hopefully you notice that it's adding 2 every time. Okay. So that is something that will show us that it is an arithmetic or arithmetic, kind of doesn't matter how you pronounce it, but an arithmetic sequence is a sequence in which the difference of consecutive terms is constant. Okay, what that means is, okay, arithmetic sequence is when we add or subtract by the same number. Sequences have patterns, so if it's an arithmetic sequence, what makes it special is we're adding or subtracting by the same value. That number that we're adding or subtracting by is our common difference. Okay, so in this, then the sequence above, our common difference would be 2, because that's what we're adding by every time. Okay, so the common difference. We usually just abbreviate it with the D. D equals for a common difference. So let's practice some problems here on the next page. I'm going to jump to the check your understanding. So I'm going to have you guys look at these 3 problems. So for 6 and 7, determine whether each sequence is arithmetic. And if it is, state the common difference. So let's look at number 6. Is this sequence arithmetic? Okay, well, let's look at what the pattern is. 3 to 8 would be adding 5. Now, is that consistent with every other number? Well, 8 plus 5 is 13. Plus 5 is 18. Plus 5 is 23. So the answer for this is yes, it's arithmetic. And our common difference then is 5. Let's look at number 7. The numbers go 1, 2, 4, 8, 16. Is this arithmetic? Okay, well, remember, arithmetic means we need to be adding by the same number. Okay, it's got to be consistent. So if it gets from 1 to 2, that means we would add 1. But to go from 2 to 4, we would have to add 2. So really, no, this one is not arithmetic. Okay. So in number 8, we have an arithmetic sequence. They want you to fill in the blanks. Now remember, if it's arithmetic, that means that every number you put in there has to be added by the same amount. So figure out what the common difference is. Maybe start with these 2 numbers. And then fill in the missing blanks. Okay, if you did it correct, the next number should have been 37. Okay, then 46. Then 64. Okay, it's adding 9 every time. All right, let's jump to the next part. So we're going to skip to this where we talk about different formulas. So finding the value a of n plus 1 in the formula you wrote. We didn't do number 9, but we can do this using something called the recursive formula. So the recursive formula is used to determine a term of a sequence, okay, when you know one of the preceding terms. So what that means is you know the term that comes before it. Okay, so let's, for example, look at this sequence here in this example below. Okay, this is an arithmetic sequence because it's adding 2 every time. Okay, and you see those dots? That's what it means by this pattern is going to be continuous. It's going to keep going on forever. So we can keep adding 2 for infinity. So what these formulas tell us is how, if we needed to find, say I wanted to find the 10th term in the pattern. Okay, we could keep repeating this until we get to the 10th number. That's fine. Remember, that would be listed as like A10. Okay, but what if they asked you to find A50? The 50th term in the sequence. If that's the case, I don't want to sit here and add 2 to each term until I get to the 50th number. So the way that we can find any term in the sequence is by using these formulas. Now, the recursive formula you can only use if you know what the term before it was. So in order to find the 50th term, for example, I would have to know what the 49th term was. So that one's not very helpful in my opinion. The one we're going to use the most is the explicit formula. So make sure you write this down somewhere. You're going to need this formula. Okay, so what this formula is saying is you can find the nth term in any sequence if you take the first term plus the common difference, and then the term you're trying to find, that's your n minus 1. Okay, so we're going to put this to use, and you'll see how we use this formula here in a second. But let's go to the next page and do number 16. Okay. So number 16, they want you to find the 40th term where the first term is 6 and the difference is 3. Remember, our formula is this. We're going to take the first term plus the difference times n minus 1. Okay? So the nth term, the n in this problem, is the 40th term because that's what they're asking you to find. So that's our n. We know our first term is 6 and our difference is 3. So all I have to do is just plug this into the formula and I'll get the answer. So my first term is 6 plus the difference, which was 3, times n minus 1. Well, 40 minus 1. That will tell us what the 40th term is. Okay, so all we have to do now is just punch this in a calculator and we are done. So let's do that. So we have, what is that? 6 plus 3 times 40 minus 1. So that would be 123. Okay, so again, what that means is this sequence that starts with 6 and then adds 3 to every term. If we did this 40 times, the number should be 123. Okay. In B, so this is A, let's just mark that. Okay, in B, they want you to find the 30th term, so there's our n. Okay, so in this problem, I'm just going to write n is 30 of this sequence. So let's see, our first term, because we need A1, the first term is 37. That's the first number that's shown up there. So the only thing else we need for our formula is the difference. So in this problem, what is the difference? Meaning, what are we adding or subtracting by every time? Now, hopefully you notice that this is going down, so we are subtracting a number. So every time we're subtracting 4. So our difference here is negative 4, since it's subtracting by 4. Okay, so let's plug it into our formula. We have the first term, which was 37, plus our difference, which was negative 4, times n, which was the 30th term, so 30 minus 1. Okay, let's plug that into our calculator. So I have 37 plus negative 4 times 30 minus 1. So negative 79 would be this answer. So the 30th term would be, I already forgot it, negative 79. Okay, and that's how you find any term in a sequence. If you know the first term and the common difference, you can find any term in that sequence. Okay? So we're just going to wrap up here at the end. I'm going to have you guys try A and B. So let's start with those. So for A, it says find the 50th term when A1 is 7 and D is negative 2. Okay? So take that and plug it into the formula and see what you get for A. Okay, if you did everything right, you should have gotten negative 91. So remember, n is their 50th term, so that's what you plug in for n. So your problem should have been 7 plus negative 2 times 50 minus 1. And just punch that in a calculator, you should get negative 91. Okay, let's look at B. Find the 28th term in the sequence if our sequence goes 3, 7, 11, 15, 19, ... So on forever. So find the 28th term for that sequence. If you did this one correct, you should have gotten the answer was 111. So this one you had to do a little work first to set it up. So we're finding the 28th term. So that's your n. Our first term in the problem is 3. And our difference, if we look at our pattern, it looks like it's going up by 4. So our difference was 4. If you plug that in, you should have been able to find all of those. Okay, so we're going to end it there. So as long as you can use that formula, you should be good for this lesson. Okay, so again, if something is an arithmetic or an arithmetic sequence, okay, if you're adding by the same number every time.